Hi everyone, this is the first video for another series of tutorial to learn the HEC-HMS model which follows from the previous 3 videos. In this video, I will demonstrate how to simulate and calibrate the previously developed HEC-HMS model using short-term rainfall event for flood runoff flow analysis. Before starting the modeling work, you need to download the input data for short-term rainfall event with hourly precipitation and discharge amounts. So for that, if you go to my GitHub repository, you can find this HEC-HMS model simulation folder. In here, you need to download this input data. This first one, just click and you can download this one. Okay? And after download, if you open the Excel data, you can find this prepared data with the date, time, and precipitation and discharge. Actually, this is one flood events for the dam watershed. So this would be dam inflow with this flood events. This is 4 days event data for the flood amount. So this is hourly data. And you can see all the hourly precipitation amount as well as this discharge amount for that. So we will use this data, our HEC-HMS model simulation and calibration. So finally, we will make this simulated stream flow amount with the HEC-HMS. Okay. So in this HEC-HMS main interface, you can see this base model. So if you collapse this one, so far we developed this base model as well as associated this terrain data only. So based on that, we will make another components with the time series data. So this time series data manager we will use. So if you click this one, you can find this new window for the time series data manager. So firstly, I will make precipitation gauge with the time series data. Okay. So if you click this new button, so we can create this new gauges for precipitation. So I will write some description for this one, watershed average. This would be, the precipitation would be watershed average amount, so I just click this one. After that, I will make another time series the gauges with the discharge gauge. So if you click this new button, also the same, I will use the gauge name with the gauge 1, but discharge description would be discharge for outlet. So this charge for outlet point. Okay, so I just created these two gauge network. So if you close this one and if you see this Explorer window, you can find this time series data folder, new folder, and then we can find this precipitation gauges as well as discharge gauges on here. So with that, I will insert the observed data for these two gauges. So firstly, precipitation gauge, gauge 1. If you click this one, you can find this component editor. So I will change this time interval with the 1 hour. Okay. After that, if you click this one, you can see another option for the time window, table, and graph. So for the time window, you need to insert this start date and time and date and time. Okay, so I will insert based on this time series data. So this time would be, the start date would be August 17, 2014. So go back to this one. So August 17 AUG and then 14. Okay, so you can copy this one and then use this end date. So this would be 20. And then start and end time would be the 12 o'clock. So this end time would be also 12 o'clock. So exactly 4 days event. After that, need to click this table tab, and then if you go to this data file for the Excel, then you need to copy all this hourly data to this table. Just paste, and then you can see this data. If you click this graph tab, and then you can see this precipitation graph with hourly data and then precipitation amount on here. Exactly same with this data. Okay, so I just created this time series gauge for precipitation. Okay, the same manner you need to make this discharge gauges the information you need to change. So firstly select this one and then change time interval with 1 hour. After that click this one. You can also see the same time window table and graph tab. So in here I will also use the same start date with 17 August 2014, then same but 20 August, and the start time would be 12 o'clock and this end time would be also 12. So after that you need to insert this table with this copy from this discharge amount. So select and copy and go back to this table and then paste on here. You need to check this starting the time with the 13. So if you blank one blank, you need to insert by yourself with the same amount 15.515. Okay, so after that you can safely insert with the observed data, and then you need to check this graph. So you can see this dam inflow graph for this outlet points for this watershed. Okay, so I have just inserted all the required actual gauge information for the discharge gauge and this precipitation gauge. We just created this one with the observed data. Okay, so based on that I will create another components for the meteorological model. So you can click this meteorologic model directly. Also you can use this component and this meteorologic model manager. So if you click, and you can create a new meteorologic model with this new button. Okay, so I will create without any description for this Met1. So after that, if you close this one, you can see this meteorologic models. The folder is just created. So if you click this Met1, you can see this component editor required to check. So on here I will use this precipitation with the specified heitograph, so you don't need to change it, but sometimes with multiple gauges you can use this gauge weight as well. But in this video tutorial I will use just this specified heitograph option. And also you need to check this replace missing data with the set to default option. Okay, after that, if you go to this Bayesian tab, you need to also check with this included sub-Bayesians would yes. Okay, and then the other option just leave as a default. So I just change this one, and then if you click this specified heat-graph, you need to check all the gauge information for all these sub-agents. So we just have one gauges for this watershed. So with the average data, you need to just insert and check with all the gauge one for these all different sub-agents. Again, if you have multiple gauge network for this kind of simulation, you can specify different gauge information for these different sub-agents. Okay, so but in this case, I just used the averaged precipitation data. So you just need to click with this gauge one. Okay, so I selected all these gauge options for this specified heat-graph for this MET one for this meteorologic model. Okay. The other thing you need to arrange with this observed data would be this Bayesian model. So on here, on Bayesian outlet, if you select this one, you can see this option tab. After that, you can link this observed flow data with we just developed the gauge one, this discharge one. Okay, so you need to check this gauge one. So go back to collapse this Bayesian model. Okay. At this point, you need to save all the processed the project with this Save Current Project button. Okay. So in this video, I have created two new components for the simulation of HEC-HMS model with the meteorologic model and time series data. After that, I linked the time series observed data for precipitation with the meteorologic model and discharge data for Bayesian model. Then the other required processes to run this model with linked flood events will be continued on the following part 2 video. Thank you for watching.